Greetings, fellow mathematicians. We're going to go through everything that you need to know about the product rule. First, we're going to go over what it is. Second, we're going to go over some tips on how to apply it. And third, we're going to go through a few basic examples so that way you can understand how to apply the product rule. Now, one of the examples that we'll be getting to is finding the derivative of y equals x squared times e to the x. And the first step to applying the product rule is you'll want to identify the individual factors or functions. And that's really simple. Just go to the multiplication sign. What's on the left of that, we call the first function as we read left to right. And what comes after the multiplication sign, we call the second function. Now with that out of the way, let's get to the three standard versions for the product rule. The first version is written with differential notation for the derivatives. The second version is written with prime notation for the derivatives. And the third version, which is very similar to the second, we just suppress the function of x notation. This is shorthand notation. All right, now all three of those versions say the same thing for finding the derivative of a product of two functions. You find the derivative of the first function, multiply it by the second, and then add to that the first function times the derivative of the second function. Pick your favorite version here, memorize it, write it down as you go through problems on homework, quizzes, tests, and exams, and you'll get the hang of it. Now, one thing I want to point out is the product rule is foolproof. Here you have addition, and order doesn't matter with respect to addition. You have multiplication, products. There you can switch the order of multiplication and it doesn't make a difference either. So here, the product rule is foolproof for plugging in the functions and derivatives. You just need to keep in mind how you apply the product rule. You differentiate one function, multiply it by the other, and then add to that the other combination. All right, now with that out of the way, let's go ahead and get to some tips on how to apply the product rule. And the first one is a general problem-solving strategy that I call divide and conquer. And what this is we take a complicated problem and then divide it or split it into several simpler problems. And if you can solve those simpler problems, you can solve the harder problem. Now what that looks like here for applying the product rule to calculating derivatives is the first step, you identify f and g of x. Second, you're going to want to calculate their individual derivatives, f prime of x and g prime of x. And then third, you just combine them all back together using the formula for the product rule. Now, the second tip here is organizing your work. And that's a great habit to get into as you start to practice the product and quotient rule. I'm going to have the quotient rule linked down below in another video in the description. All right, now I'm going to arrange the work as we go through problems in the third part as follows here. We're going to put f of x and g of x at the top, and then right below their individual derivatives. Your professor might have the work here arranged slightly differently, but it's equivalent. All right, so that's the method of divide and conquer. It works for the product rule, and we'll also see it to be used for the quotient rule. All right, step two, or tip two here, we already mentioned, organizing your work. But the third tip is incredibly important. Rewrite before you differentiate. In other words, you might have something that's written as a product, but if you simplify it, typically by multiplying it out, you might be able to avoid using the product rule. And that might make the question easier. Now we're going to point that out again through some of the problems in the third part. Before you get to them, maybe copy these down into your notes. That way you can have them in front of you as you go through problems. Let's go ahead and get to those problems. Our first problem is really simple, but it's a good example to understand how we apply the product rule. Now we're going to try applying divide and conquer here, and the first step is we want to identify f of x and g of x. Here, that's really simple. We have x squared times e to the x, so we'll say x squared is f and e to the x is g. Now, with your work, which is tip 2, you want to have it organized. I'm always going to write it as follows here. Your professor might have your terms f, g, f prime, and g prime arranged differently, but it's equivalent. So let's go ahead and write them down. We're going to say f of x is x squared, and g of x is e to the x. From there, we're going to want to calculate the derivatives f prime and g prime of x. And here, that's going to be really simple. We're just going to use the power rule, and the derivative of e to the x is itself e to the x. All right, the calculations here aren't too bad. Go ahead and apply the power rule. Bring the power 2 down. Subtract 1 from the exponent, so you'll get f prime of x as 2x. And if you differentiate g of x, the derivative of e to the x is itself. So g prime of x is e to the x. And that's most of the work for this problem. The last step, we just need to combine everything back together with the product rule. Now, if you arrange your work like this, like I will, your f prime times g term, that's your first part of the product rule. That's that diagonal product. So let's go ahead and write that down. So here our function was called y. We're going to write the derivative as y prime. And if we go ahead and combine the pieces here, we have 2x times e to the x. And then we add to that f times g prime, which is the other diagonal product here. And if we go ahead and put that in, we have x squared f of x times e to the x, which is g prime. So x squared times e to the x. And that's basically it. Now, in the beginning of my Calculus 1 course, I always like to write the terms below there. So here, 2x, that's f prime. E to the x, that's g. And this product, that's f times g prime. You don't have to do that as you're going through problems, but I find it helps my students understand how to apply the product rule. All right, now we're basically done, but a good habit to get into is once you calculate a derivative, see if you can simplify it. And what you might notice here is with each of those terms, you have a factor of e to the x, so we can factor that out. And inside parentheses, we're going to have 2x plus x squared. And that's it. This last step, very common. Once you calculate a derivative, try to simplify it. That's going to make some of the other topics a little bit easier once you're comfortable calculating derivatives. All right, this problem, again, very straightforward. The point here was just to understand how we apply the product rule. Let's go ahead and get to problem 2. Problem 2 is very similar to the first problem, but it's going to be a good example to show tip 3. You might have an easier time for calculating your derivative if you first rewrite the function. And here, the only thing we can really do is rewrite the square root of x as x to the 1/2 power. And from there, we're able to apply the power rule to differentiate x to the 1/2. Now we're still going to go through divide and conquer, so let's be consistent. Let me write down f of x, which is going to be x to the 1/2. And g of x is again e to the x. All right, the derivatives here, again, are very simple. Power rule, and the derivative of e to the x is itself. So we get for f prime, bring your power 1/2 down, and then subtract 1 from the exponent. Just be careful. Your exponent is 1/2, subtract 1, 1/2 minus 1, that comes out to negative 1/2. All right, and g prime, that's e to the x. And that's it. We have everything we need to calculate the derivative with the product rule. We just need to combine everything back together in the third step for divide and conquer, and we'll get the derivative, y prime. All right, if we go ahead and put the pieces together, we have f prime times g, so 1/2, times x to the negative 1/2, times e to the x. And then we add to that f times g prime. So x to the 1/2 times e to the x. All right, now like example 1 or problem 1, you can here factor out e to the x. So let's go ahead and do that. And what you'll get is 1/2 times x to the negative 1/2 and then plus x to the 1/2 power. And we have our factor of e to the x at the end there on the outside. And there we go. Not too bad to calculate the derivative here. The individual derivatives, f prime and g prime, were very simple to calculate just with power rule and another basic differentiation rule. And it's really easy to simplify here. Now, one tip I want to give in terms of notation, just be consistent with your notation for the radicals here. Either use powers that are fractions or stick with square roots. And what you can do here is rewrite this as 1 over 2 times square root of x for the derivative of square root of x. Now you don't have to do that, but that's just a different way to write your answer. And we can continue from here by doing that at this point. So we could rewrite this first term, 1/2 times x to the negative 1/2, as 1 divided by 2 times square root of x. And that's multiplying e to the x. And this other term, we can just write x to the 1/2 back as square root of x. And same as before, each term has an exponential in it, so you can go ahead and factor e to the x out. But you get a slightly different looking but equivalent expression for the part in parentheses. 1 divided by 2 square root of x plus square root of x. And we have our factor of e to the x on the outside. Both of these should be fully acceptable as full credit. Each of these I would accept as full credit in my Calculus 1 course. All right, when you're ready, let's go ahead and get to problem 3. Problem number 3 is a really good example to illustrate tip 3. Rewrite before you differentiate. And here, if we distribute, we can avoid using the product rule entirely. Now, we'll go through this in 2 ways. First, we'll distribute, multiply this out. And in the second way, we will apply the product rule to verify that we get the same and equivalent answer for the derivative. So first, let's go ahead and distribute x squared into the parentheses. And just be careful, when you multiply powers of x, you add their exponents, you don't multiply them. So always good to be aware of those common algebraic errors in the beginning of Calculus 1. So here, when you multiply, add your powers, you're going to get x to the 5th power. Distribute in, we're going to get minus 2x cubed, and then plus x squared. And at that point, this is a basic polynomial. And it's really simple to differentiate, and we don't have to use the product rule. So if we crank out that derivative, just go ahead and apply the power rule. Bring the 5 down to get 5x to the 4th. Bring your power 3 down to get minus 6 x squared. And again, apply the power rule. Bring the 2 down to get as your derivative 2x. And that's it. No product rule required here. Just make sure you're aware of that. There's going to be a lot of problems scattered throughout homework, quizzes, tests, and exams in your Calculus 1 course where you might be tempted to apply the product rule, but if you rewrite before you differentiate, you might save yourself a lot of work. Now for this problem, let's go through it at this point a second way by applying the product rule. So let's write the function down again. It's x squared times x cubed minus 2x plus 1. And we're not going to distribute here because we are intentionally applying the product rule. Again, to verify that we get the same answer. All right, so we have a multiplication there. We have our f of x, and in parentheses, we'll call that g of x. So divide and conquer, let's write it down. F of x is x squared. And g of x will be all the stuff in parentheses, which is x cubed minus 2x plus 1. All right, next we're going to calculate the derivatives. F prime of x, that comes out to 2x. And calculate the derivative of g of x to get g prime. And that'll come out to 3x squared minus 2. Just remember, the derivative of x is 1. The derivative of a constant, 1, is 0. All right, at that point, we just need to combine everything back together, divide and conquer, and we're going to get kind of a messier expression than what we had in the first attempt. But let's go through it anyway. All right, we have all the pieces to calculate the derivative y prime. So that comes out to f prime times g, so 2x times x cubed minus 2x plus 1. And then we add to that f of x, which is x squared, times g prime, which is 3x squared minus 2. Now at this point, the answer for our derivative looks very different from this, the first attempt, but if we go ahead and now distribute, we'll probably get an answer that looks very similar to that. So let's take our time. We're going to distribute 2x into the first set of parentheses. And here we're going to get 2x to the 4th. Remember, add your exponents. There, you're going to get minus 4x squared, and then plus 2x. And we're going to distribute x squared through this set of parentheses. All right, and again, take your time, add the exponents. We'll get 3 x to the 4th, and it looks like minus 2x squared. All right, now at this point, we can combine some like terms, and I see that we have some common like terms of x to the 4th. If we go ahead and add their coefficients, 2 and 3, that gives 5. So we get 5x to the 4th, which is the first term that we found in the first attempt, which is good. Looks like we also have some x squared terms, minus 4x squared and minus 2x squared. That combines to minus 6x squared, which again is nice. That's the middle term here. And then it looks like we have just the term by itself, 2x. There's no other x's to the first power, so that's it, so plus 2x. And that is the same answer for the derivative, but with actually more work. Notice here, we, in the beginning, multiplied out and had a very easy derivative to calculate. The second attempt with the product rule, these calculations were simple, but the end result was a little bit messy, and in the end, we still had to multiply out anyway. So just be aware of that. Again, there will be examples that your professor will give you intentionally to trick or fool you, but you're not going to fall for it. Rewrite before you differentiate. All right, now these problems were all very simple. The point of them was just to get you to understand how to apply the product rule. If you want to go through some more complicated problems on the product rule, I had them linked down below in the description, along with a link to the quotient rule. Hope you enjoyed the content. If you did, support the channel, like and subscribe.